Hi, everybody. It's Dr. Z. We're here in Chapter 16, The Scientific Revolution. This is Part 2. Okay, you just had Part 1. Now we have Part 2. We're going to start with Isaac Newton. So he was a natural philosopher. He was British physicist and a mathematician. His book, Mathematical Principles of Natural Philosophy, is a classic in classical mechanics. He also helped develop the field of calculus. His book, Principia, formulated the laws of motion and gravity, and he worked off of Kepler's laws of planetary motion and heliocentrism. He developed a reflecting telescope, the theory of color, prisms, and he's known for his work in physics, specifically gravity, optics, and the three laws of motion. And you see in his picture here with the prism and the solar system, and then also the apple falling from the tree, right, demonstrating gravity. So one of the things to think about in this time was that not everything changed. Yes, people like Galileo and Newton and Copernicus were really rethinking the world as it had been constructed by the Greeks and the medieval Christians. However, alchemy and astrology. Okay, astrology is like, what's your sign, right? Like for example, I'm a Sagittarius, right? That's astrology. Alchemy is making anything into gold, right? Trying to take other elements and things and magically turning them into gold. So alchemy and astrology continued to appeal to elites in Europe and some natural philosophers, in part because they shared with the new science the notion of a predictable and knowable universe. At the same time, many people continued to believe that the cosmos was governed by spiritual forces, right? So science at the time included alchemy and astrology. It does not today. Science at the time also included Christianity, and it does not today. So natural philosophers who continued to hold traditional views of alchemy and astrology include Paracelsus, Johannes Kepler, and Isaac Newton. Kepler, you remember, was the one with the elliptical rotations of the planets, orbits. So Newton, he, along with being a father of classical mechanics and calculus, he held traditional views. He was a devout Christian. He studied biblical chronology and alchemy. His studies and religious ideas were hesitantly accepted by Orthodox preachers, the Christian Orthodox preachers, because science was seen as a way to combat the emotional issues related to superstitions and also the threats of atheism. If scientists were going to prove the existence of God, then they were going to be a key to the factor of fighting atheists. So English deists, and deism is something we'll talk about moving forward, but for now, just think of deism as the idea that there is a God, but there isn't religion, that God created the world, but we kind of go through it on our own, and God doesn't really have a hand in day-to-day human events. That's the idea of deism. So English deists use Newton's ideas to demonstrate the possibility of natural religion, right? So they're creating not just natural philosophy, but also natural religion. And Newton tried to fight against the mystical elements of Christianity. Basically, he wanted to use science to prove the existence of God. And that was why those Orthodox preachers really liked him. He believed that alchemy, math, and astronomy would tell us the truth about God's creation. Switching gears a little bit, there's two other natural philosophers, or just philosophers really, that we can talk about. So Francis Bacon, okay, and Rene Descartes. They defined inductive and deductive reasoning, and they promoted experimentation and the use of mathematics, which would ultimately shape the scientific method. So they really helped create that. And along the way, okay, Francis Bacon also is a father of what we call empiricism, and that's basically the use of data. So Bacon rejected Aristotelian and medieval methods of speculative reasoning, and he used direct observation for scientific inquiry instead. Inductive reasoning is what this is called. Make specific observations, then broader generalizations and theories. So you start narrow and then go to wide. Monkeys, as an example I've written here, monkeys are seen using sticks as tools. Can other animals also use tools, right? You're narrow, you're on monkeys, and then you widen it out to other animals. And that's the idea of inductive reasoning. His followers in England made the Royal Society. This was supported by the British monarchs. It's still in existence, and the Royal Society purpose is to conduct scientific experiments and discussions. Many other European states had royal academies or royal societies of science. So Bacon's idea of empiricism then was the philosophy that knowledge is based solely on observation and measurement with instruments and sensors and other sorts of numerical data. So use data, right? Fact-based, measure things, and that is what empirical science is. Just as an aside, when we use data in history, we call that empirical history, right? So this is a word that's used quite often still today. René Descartes is another philosopher at this time, and his whole idea, natural philosopher, his whole idea is that matter is made up of corpuscles, built on the ideas that the Greeks had about atoms. And yes, atoms, we know atoms, neutrons, protons, right? We learn all of this in science class. And these early thinkers, without being able to see them in a microscope, had an idea that they existed, which I think is really, really fascinating. So Descartes says all matter is made of these corpuscles, tiny particles that collided together in an endless series of motions, like the workings of a machine, right? And we know that this is kind of what atoms and protons and neutrons and electrons do, right? So it's kind of cool in that way that he figured this out. He also says all occurrences of nature could be analyzed as matter in motion, and the total quantity of motion in the universe was constant. He also thought vacuums were impossible, and he was wrong, of course. Descartes is certainly known for Cartesian dualism, which comes from his name. And this is the idea that all reasoning can be reduced to matter and mind. He believed that God gave man reason so that he could discover the truths of creation. He used deductive mathematical reasoning as opposed to Bacon's inductive reasoning. So as an example, I wonder which animals use tools. Monkeys use sticks as tools, right? So that's deductive instead of inductive. Both men contributed to the scientific method. There was lots of work on illnesses. In the medieval world, medieval people thought that illness and disease was a disequilibrium of the humors. And go ahead and pause here and read this on your own. And then in the scientific revolution, what did they say? Anatomical and medical discoveries by physicians presented the body as an integrated system, challenging the traditional humoral theory of the body and of disease. Okay, so they really started to come up with different things. They did a lot of dissections. This is a picture from a medieval, a book of showing medieval dissections. I actually went to Padua this year and in a museum took some pictures of these documents for you. So here we have the medieval physician basically telling more or less the butcher what to do into cutting up the body. Whereas Andreas Vesalius, who sort of modernized the idea of dissections of human bodies, created an anatomical theater. This is a photograph I took in Padua of his anatomical theater, where people would watch dissections, and he was a physician who actually performed the dissections himself. So in conclusion, what do we get from the scientific revolution? And our AP gods tell us that the spread of scientific revolution concepts and practices and the Enlightenment's application of these concepts and practices to political, social, and ethical issues led to an increased but not unchallenged emphasis on reason in European culture. I would add to that not only is the Enlightenment coming up as a result of the scientific revolution, but also the Industrial Revolution. So there's more to come in the world of the history of science. Thank you, and have a great night. Bye-bye.